Hello everyone. In this video we will talk about kinematics of a particle, work and energy. Now in the earlier video we discussed force and acceleration. Now this is a continuation. So the energy U is basically the integral from R1 to R2. That's the radius of FdR, which is also, if it's going in a straight line from S1 to S2, F cosine theta ds. Now if we actually solve the integral, we get F cosine theta times S2 minus S1. Now this is if we draw the curve of the F cosine theta and over S is actually the area under this curve is the energy. So in case you get a problem that's giving you a curve and then it's asking you to get the energy. Now for a spring, the energy is 1/2 ks2 squared, this is the 2, minus 1/2 ks1 squared. Now energy is conserved. So the conservation of energy, we have T1 plus the sum of the energies equals T2, where T is the 1/2 mv squared, and v is the velocity. So the speed of the particle, how fast it's going. So let's do this example. We have this body on an inclined surface 10 degrees, it's moving 20 feet per second, and we have the weight 3500, and the friction coefficient is 0.5. So first we do the free body diagram. Always do the free body diagram, it's very important. So we have the weight, we have the reaction, and we have the friction. So to get the friction, it's just the mu k times the reaction, and the reaction is actually, if we do the sum of the forces in the y direction, well, in this direction perpendicular to the surface, we can get it to be 3500 cosine time, which is the weight times this is 10 degrees. And though, so we get the value. Now let's do the energy equation. We have, this is 1/2 mv squared, which is 20. And oh, actually the body goes to stop, we want to find the distance it's going. And this is 1/2 mv2 squared, which is actually 0. So solving, we get this. So the only forces in the direction of the body is we have friction, and we have the weight. We have the weight too. So for the weight, we have to take the coefficient that is parallel to this. So it's 3500 sine 10 times the distance s minus the friction times the distance s. So we get s to be 19.5 feet. This is a very simple problem just to get a better idea. Now, power is the rate of energy over time, and it's also the force times the velocity. Now if we want to know the efficiency, it's very simple. We just get the power output over power input, or we can do, or it's also equal to energy output over energy input. Now let's do another problem. We have this body, and we have two springs here. We have the weight to be 981, and it's let's say it's 0.75 meters from the first spring, and the second spring is here, which is 0.3 from the ground, and the first one is 0.4. So we do conservation of energy. Now in first state we don't have anything, so we have 0 equals, we have 1/2 ksa squared. Now sa is the distance of how much the first spring got compressed. So we have that minus 1/2 kb. Now sb, the distance of the second, is just sa minus 0.1, because it's 0.1 here. And we have the weight times the height. Now notice the minus because it's So that's the initial state. So and the height also is SA plus 0.75. Very simple. We have here the 0.75 and it moves also this distance. So if we tidy it up, we get the numbers. We have 13,500 SA squared minus 2481 SA minus 660.75 equals 0. So only one unknown, which is SA. That's what we want to find. And we get 0.331. Now, this concludes this chapter. Thank you everyone for listening.